So we would like to use the definition of the limit in order to show that the limit of 2n minus 1 over 3n plus 5 is 2/3. Let's recall how the definition of the limit works. So in general, when we make the statement that the limit as n tends to infinity of an is L, the idea is that we want to show that an comes very, very close to L, or that the difference an minus L becomes as small as possible. To this end, what we really have to check is that for any epsilon greater than 0, this signifies a very, very small number. The difference an minus L is ultimately, and when I say ultimately, I mean for large enough n, since n tends to infinity, less than epsilon. In other words, the inequality an minus L is less than epsilon is satisfied for large enough n. Practically, this means, at least for simple examples, that you start with this inequality and then you solve it, as we might say, and isolate n on the left-hand side of an inequality that says that n is greater than some quantity. We will see how this is done in this particular example. The question is, how do we check something for any epsilon greater than 0? I mean, it sounds like a nightmare to have to check something for every number, but the idea is actually quite simple. You just fix a number without revealing what it is, and then you try to show that it is true for that fixed but arbitrary number. When you do that, you have pretty much done it for every number. Let's see how it works. So we fix epsilon greater than 0. We want to show that the inequality we shouldn't write an, we know what our sequence is. So 2n minus 1 over 3n plus 5 minus 2/3 being less than epsilon is true for large enough n. What this means practically is that we're going to take this inequality, solve it for n, meaning we are going to isolate n on one side of it, and hopefully it should read that n is greater than some quantity depending on epsilon. So let's see how this is done. So the first step that we need to do here is to clear denominators. So we will do 2n minus 1, we multiply by the denominator of the other fraction, which is 3, and we have 3n plus 5 times 3, and we do this for the second fraction. So we multiply by 3n plus 5 times 2 over 3n plus 5 times 3. And now you can see that we have exactly the same denominator. So the next step is let's put everything in one fraction. So we will have 2n times 3, that's 6n, minus 3. And now be careful here, you have to put all of this in a parenthesis. So do the multiplication, that will give you 6n plus 10 over 3n plus 5 times 3 being less than epsilon. So this will give us 6n minus 3 minus 6n minus 10 over, and now let's multiply, let's FOIL the denominator just to make it a little simpler. It doesn't really matter, I mean, we could avoid this step, but I think it might make things a little simpler. The crucial step here is that the 6n cancels with the 6n here, and on the top we get minus 13 over 9n plus 5 in absolute value. Now, you can clearly see that the number that you have inside the absolute value is a negative number. So its absolute value is precisely the number that we get by omitting the negative sign on the top. So this will be 13 over 9n plus 15. There was a 15 here, being less than epsilon. And now we want to isolate n. So what do? We flip both sides, both fractions. When you do that for positive fractions, then the direction of the inequality gets reversed. And now we multiply both sides by 13, and this gives us 9n plus 5 is greater than 13 over epsilon. Now we subtract 5 from both sides, and eventually we multiply both sides by 1/9. And we have completely isolated n. And what this tells us is that as long as n is larger than this quantity right here, the initial inequality will be true, meaning the values of the sequence, the outputs of the sequence, are going to be very, very close to the alleged limit, which is 2/3. And the other interesting thing that you can notice here is that as epsilon becomes smaller and smaller, this number here becomes larger and larger, which means if you want to be closer to your limit, you will have to go further into the sequence. So you will have to consider larger and larger numbers n. And with this, we have completed what was needed. Thanks for watching.